Okay, in this video, we are going to talk about Newton's second law of motion. Newton's second law of motion. To understand the second law, we need to understand first the concept of momentum. What's momentum? Let's try to understand that. What we'll do is we'll look at momentum from two perspectives. First is try to understand it conceptually, try to understand the concept of momentum. And secondly, we will look at the math aspect of momentum. Okay, let's begin with the concept of momentum. Momentum is some sort of energy. I am writing energy in inverted commas. Energy that a body possesses, energy that a body possesses due to its mass and instantaneous velocity. Let's look at this more closely. I have put energy in inverted commas because momentum is actually not energy. In physics, energy is defined as force into displacement, which we'll be looking at in one of the other chapters. So I want you to understand that actually momentum is not energy. It is just trying to understand it from a concept point of view, that it is something a body possesses, some sort of force or some sort of energy that a body possesses because it has got mass and because it has got velocity. Let us try to take an example. Let us say this is a window pane, a glass window pane, right? And this is a stone, and we hurl this stone towards this window. And when it hits the window, it has got certain velocity. When it hits the window, it has got certain velocity. Say v is 2 meters per second. So what happens is that this stone has got velocity. It already has got some mass. Because of this combination of mass and velocity, it has certain force or energy with which it hits this window pane, and the window pane breaks. So energy possessed due to mass and instantaneous velocity. At this point in time, I want to take another example. I want to take the example of two bodies. Let us say body A and let us say body B. And I want you to understand that two bodies of different masses, say a body of mass 2 kilogram and a body of mass 20 kilogram. If this has an instantaneous velocity of say 100 meters per second, that means it's moving pretty fast, it will have a momentum of 200 kg meters per second. Whereas this body, if it has a velocity of 10 meters per second, it will have a momentum of 200 kg meters per second. That means two bodies can have the same momentum even though they have different masses and they have different velocities. I think this has helped you understand momentum to some extent, that is energy that a body possesses due to mass and instantaneous velocity. Let's try to look at it from now the math perspective. Momentum is denoted by the letter P, small p, and it is given by the formula mass into velocity. Right? So if a body has a mass of 2 kilograms and it is moving with a velocity of 10 meters per second, as we saw earlier, let's say 100 meters per second, it will have a momentum of 200 kg meter per second. That gives us the unit of momentum. Unit of momentum is kg meter per second. We have one more unit of momentum, that is Newton second, because 1 Newton is 1 kg meter per second square. So momentum is mass into velocity. I want to stress the fact that the velocity here that we're talking of is instantaneous velocity, right? So momentum is mass into instantaneous velocity, and the unit is kg meter per second. Let us look at change in momentum, delta P. Delta stands for change in momentum. Change in momentum is given by the formula m into v minus u. Mass of the body and change in velocity. Mass of the body into change in velocity. This is assuming that the mass of the body does not change. And we know that the mass of a body remains constant for velocities which are not anyway closer to velocity of light. So mass practically remains constant, and the change in momentum can happen only because of change in velocity. So delta P is m into v minus u, and the unit turns out to be again kg meter per second, because mass is a unit of kg. Change in velocity is meter per second. So delta P m into v minus u kg meter per second. At this point in time, I just once again want to write P. Momentum is mass into instantaneous velocity. I want you to understand this difference over here. When we are writing P is equal to m into v, this v means instantaneous velocity. Whereas over here, v is the final velocity. Let me show it over here. This v is final velocity. And this u is initial velocity. Whereas here, v means instantaneous, I hope get the spelling right, instantaneous velocity. So do not get confused with these two V's. When we are talking in terms of change in momentum, we are looking at change in velocity, final minus initial. Whereas when we are looking at momentum, we are looking at the instantaneous velocity, the velocity at that point in time. With this pre-knowledge of momentum, in the next video, we will be talking about Newton's second law of motion. See you in the next video.